Okay, so here we got the stock CYC controller. This one failed on me, and I went to plug it back in, and it arced on the battery, causing the connectors to, anyway, so what I did is I went ahead, and since CYC sending me a replacement, I decided to go ahead and let's figure out what went wrong. So we have the VPN, the vacuum pressure impregnated material here, and this is what you can see on the sides. It's kind of like it almost feels like a silicone. It doesn't break apart like a normal silicone. It breaks off in more of chunks. I mean, there's a lot of chunks. Anyway, so here I have a piece of, a thin tab here. We're going to go ahead and put a lighter on it. And try to get it to catch fire. And it went right out. So that's good. That's good to see right there that it went out. So that's not gonna, it's not gonna catch fire. But feeling it, ouch, that's hot. Okay, feeling it, it does thermal conduct. So if this side gets hot, the heat is gonna transfer through faster than air. But there will be heat retention here against the component where this is pressed up against. So, and there's plus and minuses to this type of stuff. This waterproofing technique. So, I managed to get it out of here. I'm gonna go ahead and take a look at the board. I got 3 capacitors here. 1, 2's underneath. Third one's on this side over here. I believe that's for each. Would like to see more of a positive, negative. A capacitor is on that as well. 3 smaller ones for each phase. The MOSFETs are down here. Looks like they use a positive and negative per side. I don't know what number these MOSFETs are yet because I haven't broken in there yet, or haven't taken these 2 halves apart and see what the part number on the MOSFETs are to see if they're medium, low, or high. But after watching videos, rotating the motor backward and having that jitteriness is a sign of the MOSFETs, a MOSFET going bad. So, upon further examination of this thing, it looks like one of these type of blade resistors, or possibly even a shunt. I'm not sure. But down here underneath this first capacitor, I should have showed you about some. I'll show you that in a minute. But down here, it's completely, whatever was there is gone. And it's not because I used a tool and scraped it off or anything. I was careful, got a hook into the material, and the material you can kind of pull it, and it pulls a big chunk off. And it pulled a big section off right here and exposed that. And that looks like what went bad. Not ruling that. That's a failure right there. Whatever that is. But if you look, when you go to place these PCB boards into here, it actually is like the capacitor is pretty much pressed up against the housing itself. There's pretty much no gap from, if you can see in there, it's pretty much pressed up against. So I mean, there's an absolutely no gap, and then it's all filled in with VPN. So, but yeah, that's where I'm at. It looks like they use 2 MOSFETs per one small capacitor per phase, 3 big exponent capacitors per phase, but I'm not seeing the well, there's obviously no capacitors for the power components. So let me give you an example here. We have CYC's 3000 watt controller, and we have my old 3000 watt controller. Now, if you can tell, we have 1, 2, and 3 for each phase, shunts, resistors. Obviously, this isn't this is a sine waves. This is an FOC, so there's a big difference in between everything. But I kind of wanted to show you the size difference, and obviously, you know, there's probably 6 FETs in here, and this one utilizes I think 6 per, and that's why I can do some back EMF on this as well, so I can do some field weakening. But that's, you know, a little bit of a size comparison. But yeah, down here is the failure by just the looks of it, because it's burned through. Looks like a copper on each side. Maybe a resistor was there. We're going to go ahead, and now we're going to go ahead and pull the 2 halves of the PCB boards off. We're also going to snip the wires, because obviously I'm not going to be using this controller again, but I can at least utilize some of the old wires and connectors if I need to extend a wire or so. It just comes in handy. You never know. So we're going to go ahead and start with the main wire. You can see it kind of just, this stuff just kind of pulls off. Now obviously, let's see, this would be for the display, which would have the pins for the 1, 2, 3, 4. I think that would be the right cutoff. Okay, so go ahead and start with power leads. Okay, power leads are gone. Now we'll do the small wire is the pedal assist sensor. Which looks okay. We'll get a little bit of a detail for you guys on some wiring schematics here. So pedal assist sensor is it's a 3-wire. It's positive, negative, and signal. It's a Hall sensor. Now whether it's a push or a pull, I'm not quite positive. In most cases, speed sensors are a push. Most cases. But in FOC it might be reversed. So, got the main and the speed sensor, or the pedal assist sensor, which is the magnet on it. It's a positive, so it's a push. And the signal reads on the push side. Now we have the speed sensor, which is a positive, negative, and a white, which would be corresponding with another Hall sensing type. positive and negative wires. And we'll go ahead and pull out the speed sensor wire because it's a longer wire. And then we have, the speed sensor has white, red, and black signal, ground, and positive. Sorry if I'm not doing this close enough. Then we have the pedal assist sensor wire, which is negative, positive signal. Okay, and then we have the display wire, the main body wire. Let's see, I got some silicone still stuck up here, and this is my job. So I could waterproof the holes a little bit better. Okay. So now we can check out this wiring. So we have a positive, a negative, I'm not sure how well the display works. Okay, positive, negative signal, ground. And the other one might be data for this green. Because you have a primary Hall sensor wires, which are, oh, look at that. I didn't even unsolder it, I just pulled it off. Do you guys see that? I just barely pulled on that, and that the solder just broke off of the bottom of the phase wire. Wow. That's a cold solder. If you guys can see that. That's a cold solder. Wow. Okay. Wasn't expecting that, so there's the blue phase wire. All I was trying to do was move it so I could see where these went. So we have the main positive from the PCB board up to the display. That turns the display on and off, which turns this controller on and off. Then we have our negative, and then we have our signal, which is going to be green for the throttle. I don't know what the yellow's for. Negative, ground, signal, display. Yeah, okay, that's right. Now we'll go ahead and snip those out of the way. Positive, negative, display, throttle signal. And there's the 1. So positive, negative, throttle signal, display. It's also easy to read it down here on the board if you know what these letters mean on a PCB board. Okay, so now we should have the corresponding Hall sensor wires on this side where the phase wire came undone. Recommend to change those out if you have that one. Yeah, CYC has an adapter, but if you do have the soldering skills, and you know, obviously these are color coordinated, and they color coordinate to the other corresponding side. So you could, in theory, you can go out and get one of these off the internet and just switch it out. Just do a hard solder between these lines and here instead of an adapter in between. obviously, if you have the motor to match this type of plug, you'll have to hard solder on the other type of plug that you want to use. So I'm holding the wires so they don't pull while I'm getting this silicone off that I put on. Sorry, my hand's not working that well today. It's pretty swollen. Tore a tendon. Okay, so now I have the corresponding. Where's my screwdriver? It's okay. Just use this for now. Just gonna get rid of this glue. Then we have our corresponding wires on the phase side. Get rid of some of this. There we go. So we have our positive, our green phase, temp sensor on white, orange, which would be this red/orange phase wire, and then the last yellow one on the hall sensor is the yellow phase wire itself. And then we're going to go ahead and test the solder capability of these other phase wires. We're going to get this little bit of a pull. That one's good on there. Let's give the positive, or the B, B1, B side a pull here on the red. It's nice and firm. I had one cold weld on the thing there. So now we'll go ahead and we will attempt to pry the two PCB boards apart. Here we go. There we go. We're getting there. Okay, so pull it. This one, we're going to pull this one up. It's got a signal wire here that it goes under this capacitor. All this stuff. The capacitor with all this stuff. I think maybe even the capacitor might have pressed up against that spot, causing the arc. Anyway, don't know exactly what happened. I'm not worrying about these junction connectors at the moment. Those go from board to board. We just want to remove this board so we can see what's all under here. Since we know this top PCB board, there's a temp sensor right here for your MOSFETs, which is roughly in the middle, right about here. Here, I can see the indentation on the VPN. It's right there. Okay, you can see this VPN is, you can kind of take it and peel off a big chunk. Peel off a big chunk. Here's the MOSFET. What I've ended up having to do at some points is take a tool and kind of get in there, peel it up. Okay, so there's more MOSFETs than it actually looks. I will look at the number later on, see which value of MOSFET that CYC uses. Not quite sure now, but we'll take a look and see how many we have. See what kind of lower PCB board we're dealing with here. I'm just trying to hook it so so I can peel it up in little chunks and not actually damage any components themselves in the process. We got battery 1 junctioned over to the negatives directly across the MOSFETs. That's not something I like seeing. Okay, since we already got those out of the way, we'll go ahead and get these phase leads out of the way. There's a lot. Looks like there's a lot more packed in there than originally looks like. Although looks like that's the culprit right there. See, I'm not trying to damage any MOSFETs, just in case anything were to happen in the future, like a MOSFET were to go out and I need one. I can still test them through continuity and everything, see if they actually... That's what YouTube is for. You can check on how to check MOSFETs. And there's a good video on how a guy explains it. Well, a bunch of good videos. But this, essentially, on how many we have here, not necessarily the capacitor voltage, because those are at 63 volts at 470 Faraday, which is the same capacitors that I have in my other 3000 watt controller. That had a thermal temp sensors go out on me, so pretty much redoing the whole controller, doing new leads, thicker wires, stuff like that. Okay, I see how they're bridged. So each MOSFET has a positive, each corresponding phase has a positive and a negative MOSFET. You can definitely see where the got some light in here. Phase lead was right here. That's where the blue one was cold soldered on. That's where this one was cold soldered onto here. Even though the VPN kind of held it together, bet you that's what caused this cold solder. Bet you that's what caused the rest, that one malfunction down here in this series. Because here, I don't know if you guys can see, we have these two have like a nice metal bridge in the middle. So these are all on one like negative, and these are all on like, and these are on positive, or it's, you know, positive and negative, vice versa. But you can see this right here, this set, that set right there is one phase. So that'd be like came off. Yellow. So this would be your yellow phase. Okay. Then you'd have your red phase up in this corner. Which this row right here would be negative. This right here would be positive. So we have a total of, you have a negative and a positive. So double FETs on each. So that's 4 per negative, 4 for positive. So that's a good amount of FETs to handle the power. You can see then the last phase right here would be the blue wire, which you would see a row of negative and a row of positive. And this would probably be the positive side because that's where it goes into. Well, that's not where that part goes into. That's obviously deeper below. But positive, negative. And then if this is negative going over to this side, then these outer edges would be negative, negative, positive, positive. But it looks like the failure happened 2 reasons: cold solder and whatever went out right here. So this is where we're at on the controller. Currently waiting on a new one. Parts and pieces, some extra wires for the moment. Cover that I can modify and put into my modified motor, because this one actually, I shrunk my bottom bracket down, so if I were to actually mount this up, it'd stick out that much further. So now I can I'll trim this down and basically just shove, put it back up into place and use it just as a cover to keep rain from going up in there. I'll mount the new controller in a different location. Probably I'm going to make a new battery box, so it'll go into the box and have space and air gap and everything to be nice and perfect. So, but that's the CYC controller, all teardown. Not too bad on the quality and everything. It looks like the right numbers. I can't really tell at the moment. Yeah, they look like decent MOSFETs, just by the numbers and what I've glanced over. But yeah.